which is of relative velocity. I'll tell basically relative velocity because it is needed for two things. It is needed for actually three things. It is needed for circular tracks, it is needed for boats and streams, and it is needed for escalators. So for all of that, we need to understand what is relative velocity. See, relative velocity is basically, think of it in this way. So if I stand like this, what is my velocity? Right now, what is my velocity? You can say my velocity is 0, but that is not true. We are standing on Earth, the Earth is spinning. So the Earth is spinning around the Sun. So Earth has some velocity around the Sun. Similarly, the Sun is also spinning in the Milky Way galaxy. So because of that, everything, even if I consider with relative to Earth, there is some velocity for everything because the Earth itself is not stationary. But if I have to calculate a time speed distance and every time I'm calculating Earth's spin and Earth's rotation, I'd go mad. So for that sake of calculation, what do? We assume the point of reference that Earth is stationary. If Earth is stationary, then everything is considered with relation or with respect to Earth. Why is that? To ease calculation. Another way to actually do this, where you actually not just consider Earth to be the point of reference, when you have multiple things moving, especially when you have circular tracks, trains, etc., one way to ease calculation is to make one of the moving objects as the frame of reference. See, assume that this A is moving towards B. Okay, A and B are both moving towards each other. Suppose C is also moving. There are three objects. How many things will you consider? How many equations can you make? All of this will be very tiring. So what I could actually do instead is that instead of assuming that Earth is my point of reference, I'll assume B is my point of reference. So what happens if B is my point of reference? I'll assume that B is stationary. The way I assume Earth is stationary, I assume B is stationary. B is not moving. But what happens is that because I assume B is stationary, I have to give its velocity to somebody, right? If A is moving towards B and B is also moving towards A, clearly I have to move, I have to put B's velocity somewhere so that I actually show that things are moving faster to each other. So when people are moving towards each other, or rather in opposite direction, A is moving towards east, B is moving towards west, if they are moving in opposite direction, you have to consider that relative velocity of A with respect to B. Suppose I make B the stationary object. The relative velocity of A with respect to B will be speed of A plus speed of B. Here this is basically relative velocity of A will become equal to this. What would be the velocity of B in this case? The velocity of B in this case, since I have assumed that B is the stationary object, that will become 0. So what I am assuming is that instead of both of us running towards each other, I assume I am stationary and I give my velocity off to you, and I assume you are running doubly fast towards me. You are running towards me with both of our velocities. Why do this? So just see over here, okay. A is moving towards B, C is moving towards B. Suppose A is moving towards B at 10 meters per second, B is moving towards C at 2 meters per second. This B's velocity is say 8 meters per second. Now I could actually find out how, and suppose the distance between them is say 100 meters. I could actually figure out this, how much time would it take for them to meet, etc. A and B to meet, A and C to meet. I could figure that out. But I would say that why do all of this work? What I'll say is that let B be stationary. So A speed relative to B will be how much? Since they are moving in opposite directions, A speed relative to B will be 10 plus 8, 18 meters per second. The distance between them is 100 meters. He is moving towards B at 18 meters per second. So this would be the time taken for him to meet B. Similarly, if C and B are moving towards each other, they are 100 meters apart, their speeds will also be added. So 10 plus 2, it will be 8 plus 2, that is 10 meters per second. So they will meet in 10 seconds. So this way I can quickly calculate how much time will be taken. Now suppose C is not moving in this direction. Suppose C is moving in the opposite direction. Okay, C is moving like this. In this particular case, B and C are moving in the same direction. How much time would it take for B and C to meet each other? If they are moving in the same direction, you can say that since I and you are running in the same direction, from my perspective, you are actually running slower from me. From my perspective, I am gaining on you. I am reaching you. I am covering the distance. So what should I say? I will actually think that because we are running in the same direction, your velocity is essentially negative velocity because you are running away from me. So I'll say that the velocity of B with respect to C would be how much? The relative velocity of B with respect to C, because C is essentially running away from B, would be negative velocity. So I'd say this is 8 meters per second minus 2 meters per second, because every second I'm covering 8 meters, you are running away 2 more meters. So in general, I'm just 8 minus 2, I'm just covering 6 meters of the distance between us. So when people are running in the same direction, then you have to subtract the speeds. When they are running in opposite directions, you have to add the speeds. When they are running in the same directions, you have to take the difference of the speeds. This is the idea of relative velocity. Relative velocity, remember that the distance covered will be, overall distance covered will be same. The overall time taken will be same. But the individual distance covered by each one of them will be different. So if I say that, okay, this is, okay, let's consider between absolute frame of reference versus relative frame of reference, okay? Suppose this is like A and B are running towards each other, okay? This is 5 meters per second, B is 3 meters per second, and suppose this is 2000 meters, okay? Now if I ask you, how much time would it take for A and B to meet? They are running in, say, opposite directions. How much time would it take for them to meet? 2000 meters, they are running in opposite direction. The relative velocity will be 5 plus 3, that is 8 meters per second. Time taken will be 2000 divided by 5 plus 3, that is 8 meters per second. From this I'll get time. Whether it is an absolute case or relative case, the time taken will not change. But what changes is the time. If I assume that B is stationary, what will change is the point of meeting. So if I am considering relative velocity, I should not use relative velocity to figure out the point of meeting. Because if I assume in relative velocity terms, okay, if I say that this is A, this is B, B is moving at 3 meters per second, A is moving at 5 meters per second, this is 2000 meters. I start by saying that let's make B stationary, I'll transfer all the velocity to A, and A will move at 8 meters per second. Then you will say that, okay, they meet at this point. But that will be wrong. They won't meet at that point. That is basically saying that when you're calculating time taken is the same whether it is relative frame or absolute frame. But if you want to find the point of meeting, that you have to do only in absolute frame. So what you should really do is, you should figure out the time taken to meet. So together, how much time would it take to meet? So 1000 by 4 is 250 seconds it would take, 250 seconds. Then you say that they meet at 250 seconds. In 250 seconds, this guy would have covered how much distance? This guy would have covered 1250 meters. In 250 seconds, this guy would have covered 750 meters. So when you have to figure out in relative frame or absolute frame, you can both, in either frame you can find out the time that they will meet. But to find the point that they meet, always consider only the absolute frame. First calculate time that they would take to meet from relative frame, multiply that by the actual individual speeds to figure out the actual point of meeting, which is somewhere over here, which is 1250 meters from the starting point of A and 750 meters from the starting point of B. This is the only two things that I want you to remember. Things are moving opposite direction, add, same direction, subtract, and when you are using relative velocity, use it only to calculate time of meeting. To calculate the point of meeting, use absolute values, don't consider relative velocity.